Good morning, everyone. My name is Rob Jones. I'm the Network and Exhibit System Administrator here at Tryon Palace in the North Carolina History Center. Today, I got something special for you. A lot of people don't get to experience this. Today, we are going to reset our Seth Thomas clock, made in 1911. This clock used to sit in the city of New Bern clock tower until about 1999 when it was decommissioned. Decommissioned for various amount of reasons, because these clocks are not the easiest things to work on nowadays, and we have to get a special clock master from middle part of Pennsylvania to special make us parts when parts inevitably wear out or go bad. So today I'm going to take you on a journey where I'm going to show you how I reset this clock. All right, so the first thing I got to do is I got to actually stop time. Yes, you heard that right. I got to stop time. How cool is that? Now this is how I do it. Just got quiet, didn't it? And now I'm going to stop the pendulum. Now that I'm done oiling all the ports and checking over for wear and tear, next I got to do is I got to restart the time. So this is when I have to be extra cautious about keeping my fingers and my lanyard, anything that's in my hands away from any of these gears, because gears hurt. So what I'm going to do is I'm going to restart by starting the pendulum, which is the perpetual motion. Yes, it's hard because that pendulum weighs about 500 pounds, and I'm trying to get it going. Okay. And then I just need to make sure that everything is kind of out of the way, because again, we want to be safe. And now what I'm going to do is I'm going to release the clutch when I'm ready. And when I release this clutch, you'll notice up here on the time is going to resume, but time is going to fly. So if you look up here at the clock, you can see the minute hand going at about 8 times the speed. But you're going to notice here, when I hit about noon, you're going to watch this set of gears engage, which is going to engage our bell. It's going to be loud, so just kind of wait for it. But you'll hear a couple series of clicks. Those are clutches and gears getting ready to engage. And as soon as they engage, you'll hear a hammer drop, click, click, and then the machine will start. And you'll hear it count 12. That means it's for 12 noon. The hammer just dropped, gears are in position. It's just waiting for one final hammer to drop. You'll hear it click, and then this whole series of gears will go ahead and start. If you notice the weights going up and down, we'll talk more about what the weights do here in just a moment. It struck 12 times, which right now it's off time, and it's going to have to do that all the way back till I reach the current time, and it's going to cycle a couple of times around the clock, because back then there was no AM or PM. 12 o'clock was 12 o'clock, 1 PM was either 1 PM or 1 AM, but it still chimed one time. It didn't signify whether it was day or night. You just had to assume that it was at night and it was 1 AM. So over here you're going to notice our bell. This is not the original bell. The bell for the original clock tower, city of New Bern, would have been probably 4 or 5 times larger than this. But this bell, if we would have had the original bell in this space, our ticket agents downstairs would be quite deaf. because it was meant to be heard citywide. So since it's a small space, we didn't want to deafen anybody. So the original clock restorers put in a smaller clock. But if you're going to notice here, I'd like to point this arm out here. This is what we call our hammer arm. This is not an original piece. It originally broke about 18 months ago. And that was not an original piece either. Part of the clock restoration project was they had to rebuild this clock arm. But when it broke last time, I reached out to Craven Community College, and they had their CNC department, students and instructor. They came out, took a look at the old one, 3D scanned it, and they were able to make a 3D exact copy of the original one that broke. So that being said, that they were able to completely redo this one, and it's been working beautifully for the past 18 months. And I want to thank Craven Community College for that partnership, for their skills, their knowledge, what they're teaching students, and it fit a real world application. So thank you very much. We're getting ready to notice it's going to chime one time. If it chimes 2 times, we got a problem, but it should chime just 1 time. And see what I mean by time flying? Should hear a hammer click, and then a gear click, and then it'll chime 1 time after the gears start up. And it's going to continue to do that till we hit the time that I'm trying to set. Okay, you're going to notice here, these are the weights. It's going up now, and they're going to free fall on their own. Now this is part of the original system here, using free rates or using gravity to keep tension on all the cog wheels. What was replaced in 1974 by the city of New Bern were the actual clock windings themselves. A clock person had to go up once a week, sometimes more often than that, depending on temperature and humidity and barometric pressure and all that, you know, the way the metals react. They had to go up, you know, quite often to tighten the windings, just like in a grandfather clock that you may have in your house. But in 1974, they replaced it with this GE that's a 1/4 horsepower GE motor, 12-volt motor, and they had to install a couple little micro switches for when it hit down to the bottom, it would turn on, and when it goes to the top, it hits another micro switch to turn it off. So the motor's only essential function is to raise these weights, not to lower them. Gravity does that on its own, and we have 2 of them, one on the left side and one on the right side. This side here is controlling the time, so it's the tension that is keeping that chain, this set of cogs, in perpetual motion. And it's a controlled motion. There's another set of motor and weights on the other side, but that controls the tension on the cogs for the hammer, or the hammer arm for the striking of the bell. So you'll see over the course of a day, since we're in kind of fast forward, you can kind of see it, you know, slowly going down. But over the course of a day, it's almost where you really can't see it. I mean, you would have to sit there about an hour in order to watch it slowly go down. So this is kind of a cool little behind the scenes here, where you could see the actual gravity taking effect and how things are keeping our machine in time. 1, 2. So one thing I want you to look at here is people always want to know, after the bell chimes, they always hear a residual grrrr, and what that is that's a set of gears that are right here. This is what it's doing is it's preventing it from going counterclockwise. It will only spin clockwise. So as it slows down, it's kind of a mechanism to keep it, 1, from going in reverse, but number 2, it acts as kind of a stop, or as a slow braking system. See, I can turn that freely. So that's the residual that you hear after the bell chimes. Okay, what I want you to pay attention to is right on over here before the clock strikes. This is where that hammer drops to go ahead and engage our hammer arm. So you're going to see that will hammer down, and we'll get into position, and it's getting ready to strike 4 times. So it's kind of cool the way that it works. It kind of acts like a clutch or as a release to say, okay, I'm ready to engage.